Hello guys, welcome to Infinite Insight Geometry, Lesson 1.7, Intro to Proofs. Alright, let's begin. So this isn't the first time we talked about proofs. We actually talked about proofs in 1.2, Infinite Insight Geometry 1.2, How Mathematicians Prove Things. There we indicated the steps as to how to prove something. But now, for lesson 1.7, lesson 1.8, and lesson 1.9, we're actually going to learn how to make proofs. So the title of this video should actually be the intro to making proofs. And the trick to proving statements is to use tools that apply to all instances of a problem. That way we can use them to prove many different statements. For example, if we say an even number is a number divisible by 2, then we can say that for any even number in any problem, regardless of what problem it is. Now, there are 4 main pieces of information that you need to know to solve proofs. You have the given statements, the definitions, the postulates, and the theorems. Now, the last 3, the definitions, the postulates, and the theorems, we already talked about in 1.2. The definitions, they're statements that explain the exact meaning of a word. We also talked about them when we talked about biconditional statements. They are the definition fits the word and the word fits the definition. For example, a number that is divisible by 2 is an even number because an even number is a number divisible by 2. And postulates, axioms, are statements that are assumed to be true without proof. We wouldn't have geometry without these axioms. And now theorems are statements that have already been proven true using postulates. Think of them as a shortcut. Rather than having to invoke all of the postulates one by one, we can just use the theorem shortcut as to prove things quicker. But then we have the first one of the 4 main pieces of information that I talked about earlier, were the given statements. Now, the given statements are just the facts provided in the problem. There's not really anything special about them. They change with each problem. For example, a given statement would be, in this problem, there is triangle ABC. So now you have to find definitions and theorems and postulates about triangles. But the thing is, these statements aren't always exactly sentences. There could be a figure, like a triangle might have a line in it, and you need to extract information about what that means. Like, is it perpendicular to the triangle? Are these lines parallel? Are they congruent? So, this is how you prove a statement. You just start with your given statements. Using those given statements, select any definitions, postulates, or theorems that may apply. But then you can't just use any definitions and postulates or theorems. If you're looking at one specific problem and you're trying to fit one specific theorem about a triangle in it, it might not be the correct one in order to advance forward into the proof. It might be true for the triangle, yes, but if you're trying to prove something about the size of a triangle, it's not going to help that the angles of a triangle add up to 180 degrees because they're sides. You might want to use the Pythagorean theorem or the law of cosines or something. That's why you had to make logical deductions about what definitions, postulates, and theorems should you use to prove this. And the order, because the order is also important, because there has to be a natural flow of the proof so that the proof can reach its given conclusion. So, you might already seen this before. This was the proof that 2 even numbers add to another even number in lesson 1.2. As you can see, there are a lot of words and symbols, but the basic key thing here to note is that second line in the proof, even numbers can be expressed in the form of 2 times an integer, is a theorem that was given by the definition that even numbers are divisible by 2. Since even numbers are divisible by 2, they can be expressed in the form of 2 times an integer. That is a theorem. And we can write a equals 2m and b equals 2n, where m and n are both integers, because we know that even numbers are divisible by 2. Then you can see the addition property of equality and the distributive property. Those are both theorems. We already proved those. And using all of these definitions, postulates, and theorems in a natural flow of order, we can then prove that 2 even numbers add to another even number. And most of you may consider this easy. Well, 2 plus 4 is 6. That even plus even is even. This is 3rd grade mathematics. But here's the thing. Because how do you know that this is true for every single instance of this problem? For example, if you hand checked all even integers, which is impossible because there are a lot of even numbers, they go all the way up to infinity, and check that each and every single combination of them added up to an even number, which is impossible, you might find that one of them, even plus even, might equal an odd number. So we have to use definitions that apply for all even numbers, and we had to use theorems that apply for all numbers in general to prove that 2 even numbers add to another even number. And in the next few lessons, 1.8 and 1.9, we will look at several different types of proofs that will make use of these definitions and postulates and theorems that apply for every number or every instance that they apply to. And that'll be all for today's lesson. Please like, comment, and subscribe. If you have any questions, please feel free to email me. My Gmail is in the description. Please stay tuned for lessons 1.8 and 1.9. Those will be very, very crucial to this course, and I will see you all next time.